Today we're going to talk through atmospheric pressure, how that's measured, and what it means. So air pressure is a measure of the mass of air above a given level on the surface of the Earth. Our assumptions when we're talking through this air pressure is that air molecules are not crowded together. It means they're spaced fairly well apart. The density is going to remain the same through the air column. The width of that column is not going to change with height, and air is unable to freely move into or out of a column. So we're modeling this column that this is in. So situation one in this model is that the air density, okay, so the air pressure, can be changed by changing the temperature. So you can see there's two columns here, and they start off at the same pressure, same surface pressure. But City 1 has colder air than City 2. Cold air is more densely packed than warm air, and we know that just because of gas laws and the idea of thermal expansion. Excuse me for the bell, which we talked through in a previous unit. Okay, so as substances get warmer, their particles spread farther apart. So cold air is going to be more densely packed than warm air at the same level, not at the surface. At the same level in the atmosphere, not at the surface, warm air has more molecules above it, meaning it has higher pressure. It also takes a shorter column of cold, dense air to exert the same pressure as a tall column of less dense air. Okay, so your air pressure is going to quickly drop as you move up the column of cold air, whereas it's going to drop less quickly as you move up the column of warm air, which is what point I is stating. And then also, air is going to move from high pressure to low pressure, and this is called the pressure gradient force. So if City 1 and City 2 are next to each other, there's high pressure in the warm column, low pressure in the cold column, and so air is going to move from City 2 to City 1. Okay, and once again, this plays into gas laws. If you recall from either physical science or chemistry, high temperature, high pressure. So warmer temperatures, higher pressures. Okay, situation 2, if we're starting with different surface pressure, okay, as the air in the upper layers moves from City 2 to City 1, which is low pressure, so we're starting from the end of that first situation, the surface pressure at City 2 is going to decrease. And then that makes it so air pressure is going to move from City 1 to City 2 at the surface. And so you get this cycling of in the upper air, it's moving from City 2 to City 1, and then at the surface, City 1 to City 2. Okay? To measure air pressure, we use things called barometers. Now, our standard atmospheric pressure is about 1,013.25 millibars, or 29.92 inches of mercury. Barometers are used to detect and measure pressure changes. Mercury barometers were pretty popular for a while, and they measure atmospheric pressure by measuring the height of mercury in a column. The barometer that I have in my classroom is an aneroid barometer. This is called a dry barometer because it doesn't have a liquid in it, and it measures the atmospheric pressure by measuring expansion and contraction of the aneroid cell. Now, station pressure is the barometer reading at a particular location and elevation, and you've worked with that when you've worked with those station models and writing those out. And then sea level pressure is the station pressure adjusted to a level of mean sea level. And the typical correction is about 10 millibars per 100 meters. So that gives us a little bit more information when we adjust it, and helps with weather forecasting. Okay, that is it for today. Please check Google Classroom for the rest of your assignment.